Alright, resistors. I'm going to cover this in a way that hopefully is easy to understand, because every time I looked up the information, it was taught by nerds. And I mean, we're like hardcore nerds that never taught anything in their life. So hopefully this helps. Resistor. This is a resistor color chart. Okay. Our mission is to save the blue LED from extinction. So we have to know how much current the little LED can handle and how much voltage it can handle. An Arduino unit puts out 5 volts. Okay, I know this because if you go to the Arduino website and you look up the specs of the Arduino, we have this 5 volts. It has an input voltage of 7 to 12 volts, but since there is this little thing right here, this is a voltage regulator, it takes, let's say, the amount of power in and turns it to 5 volts, and that's what comes out of the board. It doesn't go above that or below that until it's asked for. So there's also a 3.3 volts here. But notice that 3.3 volts is actually being manipulated down using current. Okay, so there's no 3.3 volt regulator on the said Arduino unit. There's only a 5 volt regulator. Alright, cool. So our mission is to save the LED, and all we do is have to ask or answer 3 questions. The 3 questions are this. Anytime I'm dealing with this, let's say a device that puts out voltage, I have to say, how much voltage is there coming out of the said unit? And in this case, I know it to be 5 volts. The rest of the little part of this is, what can the component handle? So I bought that little blue LED at sparkfun.com, and here we have the specs for it. Anytime you buy an LED or any kind of component, it has specs. In this case, I need to know the max voltage that the said component can handle. In this case, it's 3.4 volts. Okay, so let's type that in. 3.4 volts is the second part of our answer. And lastly, we have the max component current. Okay, so current, what the heck is current? I'll just explain it this way. Current is the amount of energy that goes into the component, the rate of it going into it. All right, so too high of current, basically you stand in the middle of a river and all of a sudden it rains and floods, you get knocked over, right? Well, that's the same with current. Lots of current equals death to the LED. So how much current can this little guy handle? Well, it's labeled here. We have 80 milliamps, the forward current. Okay, let's plug that in. 80. Oops. All right, let's do some math, shall we? So all is your voltage of what's coming out times the voltage of what it can handle divided by 80. Now that's pretty easy to understand, but anytime you show this to a student, Ohm's law, they shrivel up in a ball. I know I did. Okay, but that's essentially Ohm's law. So let's do some math here. Okay, we got 5 times 3.4 divided by 80 equals 0.21. And if we take the point out of the equation, it would be 21. Okay. Now, if we look at our chart, we'll find 21. Well, 21 is not on here. They have a 22, and that's what we want. Red, red, red. Or red, red, black. Now in the video I had red, red, red. What's the difference? Well, I was too lazy to go over and get a red, red, black, to be honest with you, and I had it at my disposal. But as long as it didn't go this way, I was okay. So this way, less resistance, higher current. So all of a sudden, lots of current gets to the said LED and fries it out. This is the minimum that is required. So we got to have that. And then what I had was this one over here. So it made the LED a little bit more dim. So as I go out more and more, it gets dimmer and dimmer and dimmer. Cool. So that's how resistance works. I wanted to save the LED. I had this. I could have went here to make it brighter, but the fact is I had to dummy it down because the LED could only handle 3.4 volts and the Arduino unit was putting out 5 volts. So I used Ohm's law to figure that out. Pretty cool, right? So keep Ohm's law handy and use it wisely. Enjoy.